Hello and welcome once again to the Waters and Stanton video channel. Cheap antennas, cheap HF antennas. You know, I'm sure that many of you dream about having a big antenna array. All those aerials on top of a tower. One that you can direct in any given direction. Workstations that perhaps others can't even hear. Perhaps you're located on top of a hill. You've got a lovely view of all the surrounding terrain, well above all the noise. You've got your tower on top of that hill and you're all set to go. And then you wake up in the morning and you realise, no, it was all a dream. Well, I'm going to look at some cheap HF antennas that aren't a dream. They're antennas that you can make, simple antennas, won't cost you much at all. And yet you'll get a great deal of fun out of them. And if you're a beginner, this probably is the ideal way to start. But if you just moved house and you've got a transceiver, you can't really afford to justify spending a lot of money on an antenna, well, you don't have to. There are other ways of getting on the air. So let's take a look at some cheap HF antennas that'll get you on the air, you'll have fun, and you'll be really gratified that you're having these wonderful contacts around the world. It didn't actually cost you money in the way of antennas, and also you can sleep at night when the gales are blowing. You know, the worst can happen is that the aerial will fall down and you cut another bit of wire and put it back up again.
Welcome to the Waters and Stanton Ham radio channel, presented by Peter Waters.
In this video we're looking at cheap antennas. Let me just remind you that if you're looking for a high quality, high performance, budget class transceiver, take a look at the Yaesu FT710. I've done several videos on it. It's an amazing transceiver at an amazing price. Not sure how long they're going to keep it at that price, but take a look if you're in the market for a budget class transceiver. The Yaesu FT710. Quite amazing. Here's a simple antenna we're going to develop from just one band to 4 bands. Our first antenna we're going to look at is the dipole. The dipole is the basis of many HF antennas, or antennas for VHF and UHF. But for HF, it's really one of the go-to antennas. It's a dead cert. If you erect a dipole, it's going to work. Doesn't matter how high or how low it is, it's going to work in some way, shape and form and give you a decent match. A dipole basically is a length of wire which is a half wave on whatever band you're going to operate on. So let's say, for example, you want to operate on 40 metres. That's why the camera closing down. So let's take, for example, 40 metres. A 40 metre dipole, half wave on 40 metres is 20 metres. In old money, that's about 66 foot long. And if you cut that wire in the centre and connect a bit of Coax cable to it, then you're going to have a 40 metre dipole. 50 ohm Coax cable is a good match for a dipole. The actual impedance of the dipole varies slightly. It'll be something like 70 or 60 ohms, but 50 ohm Coax is okay. You'll get a good match. So if you want a starting antenna, just put up a dipole. If you want to operate on 20 metres, then the dipole length is 10 metres. The actual formula for a dipole is 468 divided by the frequency in megahertz, which gives you the answer in feet. And I'll talk about feet because for 2 reasons. First of all, I'm of the age where feet still mean something to me. I can imagine how long a foot or 2 foot is, and our friends in America, I'm sure, will be grateful that we work in feet. The rest of you, well, you'll have to do a conversion, but I don't think that's too much of a problem. Now, if you're starting out, a dipole is a good antenna because, as I said just now, it's a surefire antenna. It works, and it works well. A dipole, we're told, should be a half wavelength above the ground to work reasonably well, or to work well. Well, there's not many of us around that can always put up a dipole at a half wave above the ground, because a half wave above the ground on the 40 metre band is 20 metres. I'm sure many of you can't put up an antenna 20 metres above the ground. So if we put it a quarter wave above the ground, which is 10 metres, 30 feet, it becomes a bit more practical. But don't really get obsessed with heights above the ground. Just use what you can do, or install what you can do. I've put up a dipole at 9 feet above the ground, 3 metres, and it works okay on 40 metres. It's not as well, it doesn't work as well as a dipole higher up, but the difference is actually the angle of radiation. 40 metres is quite an active band, and that's why I'm talking about 40 metres, because it's a band that's open really 24 hours. And if you have a low dipole, it favours high angle radiation. High angle radiation is good for short range contacts. Ranges of around about 200 or 300 miles, and if the band is in good shape and favouring short skip, you'll get some very good signals. But don't get het up with heights above ground. If you can only get your dipole up at 10 or 11 feet or 3 or 4 metres, then do it. So let's concentrate on a 40 metre dipole, bearing in mind that although it's 20 metres long or 66 foot long, you can bend it around the garden. It is pretty tolerant about bending around the garden or bending down, so you could have a horizontal section of, say, I don't know, 40 foot, and the ends, either end, drop down, or you can do it in the horizontal plane. You can have a dipole where you've got a 40 foot garden, 40 foot long garden, and you bring the legs forward at 90 degrees at each end to accommodate a total of 66 feet. So let's talk about the materials that you need. For the antenna wire, I favour PVC covered wire, because the PVC covering protects it. It doesn't have any effect at all on the radiation. So one of the popular methods of buying wire is speaker wire. If you buy speaker wire, which is twin lead, and that's PVC covered, split that in half, and you've got the basis for your half-wave dipole. 10 or 12 metres of speaker wire, pull it apart, you've got your wire for your 40 metre dipole. As regards the centre, well, you can get yourself just a centre insulator, and one side of the coax, in other words the outer sheathing, goes to one wire of the dipole, and the inner conductor goes to the other side of the dipole. As for the coax cable, I suggest you purchase some RG58 coax cable. That's more than adequate for the average garden, and it's not particularly expensive. Do you need insulators at the end? Not really, no. You can bend the wire around or tape it or whatever you do. Insulators make it look better, but it doesn't actually have any bearing on the performance, certainly at the power levels that you're likely to operate on. It's a good idea to actually make the dipole slightly longer, say, I don't know, 6 or 8 inches longer than the calculation shows. So if you make the dipole a bit longer than the calculation shows, you've got a bit of leeway then to cut it back. And the way I normally adjust the dipole is I'll check the VSWR, and if the antenna is resonance right at the bottom of the band, I might decide I want to make the antenna a bit shorter. Just bend the wire back a bit, recalculate it, and once you've got the length right, just keep the ends bent back, just tape them so you've got a slightly shorter dipole than you started with. But it's good practice to make that dipole a bit longer rather than a bit shorter. One thing that I would recommend that you purchase is a decent soldering iron. You know, a soldering iron can save you a lot of money, really, because it means, say, you can put your own plugs on rather than get somebody else to do it for you. And very often, if I've got some spare wire, I'll just solder it together, cover it with tape, and it gives me a bit of extra wire. Do you need a balun at the point where you connect the coax cable to the antenna? Well, very often I don't bother. You can purchase a one-to-one balun, and I suppose it makes a means of terminating the coax and the wire. But what is important is to make sure that you have a line isolator at the point where the coax cable is about to go into the transceiver. In other words, the first point in line might be an SWR meter, it might be your transceiver. Wind about 6 or 7 turns of your RG58 round a ferrite core. I use FX240-43 ferrite material, and what it does, it chokes off the common mode currents on the outside of the coax cable, and they can interfere with the readings on the VSWR meter, and sometimes if you've got an internal matching unit it can cause a problem there. Now this 40 metre dipole actually is a 2-band antenna, because a dipole will resonate on its fundamental and its third harmonic. In other words, the feed point in the centre is a low impedance on the third harmonic. So the third harmonic of 7 MHz is 21 MHz. 3 times 7 is 21. That means to say that the antenna actually will operate on both the 40 metre band and the 15 metre band. But there's one problem. The problem is that the harmonic relationship is not perfect. In practice, you'll find that the resonance on 21 MHz is much higher than the 21 MHz band. It's something like 21.6 or 21.7 MHz. In other words, it's resonant just outside the 15 metre band. We need to bring that resonance down, and the classic way of doing that is to add a capacity hat. A capacity hat is very, very effective if it's placed at a voltage point. If you take a loaded whip, for example, and you grab the bottom of the loaded whip, you'll find that it makes very little difference if you're listening to the signal on a receiver. Touch the far end, in other words, what would be the voltage point if you were transmitting, touch the far end, and it makes a big difference. You can hear the signals go down. So if we measure along from the centre of the dipole to a quarter wave on the 21 MHz band, which is actually about 11 feet, sorry, we're back into the old money again, about 11 foot from the centre point of the dipole is a voltage point on the 21 MHz band. We can place a short length of wire there, which acts as a capacity hat. That will have the effect of having a significant effect on the 21 MHz resonance. In other words, it will lower it, but have very, very little effect on the 40 metre band or the 7 MHz operation, because that primarily is a sort of more a current point than a voltage point. What you need to do is to add a bit of wire, about 12 inches of wire, 11 foot out from the centre on each side of the dipole. That should bring the resonance down on the 21 MHz band. Now you will need to trim that length a bit just to find out the best length. But if you add a length of wire and then just trim it back, you should find that will bring the resonance on the 21 MHz band into the 50 metre ham band, not 21.6 or whatever it is, with having very little effect on the 40 metre band. Thus, you've got a 2-band antenna, just for the sake of adding a couple of bits of wire. Now we can go further. We can add yet another band. We can add the 20 metre band. What we do is we actually create a dipole in parallel with the main dipole. Some people call it a fan dipole, but it's really a pair of parallel dipoles. And you'll see in the drawing here that we've added a 20 metre dipole. 20 metre dipole is 5 metres either side of centre. In other words, it's a total length of 10 metres cut in the centre and connected at exactly the same point to the coax cable as the 40 metre dipole is terminated. That will give us 3 bands. We'll have 40 metres, 20 metres and 15 metres, just by adding an extra bit of wire, albeit a 20 metre dipole. And that should have virtually no effect on the 40 or 15 metre resonances. We could go further. We could add another band actually. Let's, for example, say we want the 10 metre band. We could actually put a pair of 10 metre traps in the 20 metre dipole. Now 10 metres, you measure 2.5 metres down from on the 20 metre leg, measure 2.5 metres down either side, insert a 10 metre trap. That will bring that bit of wire to resonance on 10 metres, and then add some extra wire beyond those traps to bring it to resonance on the 20 metre band. And that will actually give you a 4-band dipole. You'll have 40 metres, 20 metres, 15 and 10 metres, all for just by adding wire, albeit the traps. I would suggest that you probably purchase commercial traps, because you can create your own traps, but unless you've got means of checking the resonance and so forth, it might be better to get a pair of commercial traps, but it's up to you. Now there is another antenna that I've used extensively, and that's the half-size G5RV. The half-size G5RV is 51 foot long, and it's very simple to make. You've got 51 foot length of wire cut in the middle. This time you feed it with a length of open wire feeder, or 450 ohm ladder line I use, and I'll put the dimensions up on the screen here now, and you can see that antenna is then terminated at the bottom of the 450 ohm ladder line with RG58 coax cable, 50 ohm coax cable. That antenna will resonate on 40, 20, 15 and 10 metres. It will also work pretty well on 17 metres and 12 metres. And the reason it works so well there is because the reactance at the end of the coax, where it terminates at the transceiver, is not that bad on any of the bands. It's a compromise, but if you've got an internal antenna matching unit in your transceiver, like the FT710, which has got a very great capability of matching all sorts of reactances, you should find that if you terminate that with, or feed it with an FT710, it'll operate on all bands from 40 metres through to 10 metres. So we've created several different antennas, all for the cost of not much at all, but mainly wire, a bit of 450 ohm ladder line, 10 metre traps if you need the 10 metre band, but if you go for the half size G5RV, you don't need any traps at all. You just construct it as I've shown in the diagram, and you're ready to go. And also do remember that you can fold the antenna like the half size 5RV, which is 51 foot overall. You can drop the ends down or bend them around a bit, and it will still work. Now I've kept two horizontal antennas because they seem to work pretty well, and they are not so prone to picking up noise as vertical antennas are. But if you want to try a vertical antenna, then I did publish a simple design a few videos ago. I described it as the invisible antenna. It's just 13 foot high, fed with a 4:1 unan, and that works pretty well on the ham bands from 20 metres through to 10 metres. Alternatively, you can put up a simple quarter wave of wire. Say for example you want to try 20 metre vertical. Then you just put up a length of wire around about 16.5 foot long. If you've got a tree nearby, you can just dangle the wire from the top of the tree. If you haven't, get yourself a short fiberglass pole and use that to support the wire, and then just connect 50 ohm coax to the base of it. But you do need to put some radials down. I would suggest you need something like 8 radials or so, around about 3 metres long. Oh, gone back to metres, haven't I? About 3 metres long or a bit longer to act as a ground plane. And that will work very well, and it will give you some idea of whether a vertical is going to be a good investment in your garden, because we do some excellent verticals, the Hustler vertical, which covers 40, 20, 15 and 10 metres. And if you haven't got a major noise problem, then that sort of antenna might be something to invest in, because it's self-supporting, it'll handle high power, and it's very popular, lasts you for years. So if you're thinking about a vertical, try a quarter wave vertical in the garden, see how it works, and if you're happy with that, then you can perhaps invest in a commercial antenna. So there we are, that's some ideas for you to play around with. A bit of wire, a bit of coax cable, and quite a lot of fun in the process. You obviously need to have a VSWR meter to just check the antenna, but of course that's built into your transceiver these days. If you really want to get into antenna design and manufacture, but making antennas, then I suggest one of the Zoom antenna analyzers. They are so effective, save so much time. You can be messing out in the garden there with the antenna, plug it into your Zoom antenna analyzer. It will tell you immediately how it's going, whether it's going to resonate, etc, etc. So have a look at the range of Zoom antenna analyzers. They're a great investment. If you buy a Zoom antenna analyzer, it'll last you for years, and they're very effective, very time saving. There we are. So thank you for watching this video, much appreciated, and thank you for your support on this channel. Don't forget to press the subscribe button. Don't forget that we've got a wide range of ham radio equipment And if you've got any queries, just give us a call. If you're thinking of buying something or you want to do a part exchange, we're happy to do some sort of deal. I'm sure we can strike a deal over the phone or via email. So don't forget that. In the meantime, enjoy your ham radio, you take care, and as usual, I look forward to seeing you in the next video. Bye for now.